Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through everything you need to know about percentages, ratios, and rates for your upcoming test. So everything you need to know about percentages is in blue, ratios in black, and rates in red. Let's get to it and go through each of these things. So percentages are just fractions whose denominator is 100. For example, 73% means 73 over 100. So you can write percentages as fractions or decimals, and this is how you convert between them. To go from a percent to a fraction or decimal, you divide by 100. To go the other way, you times by 100. So when we have two quantities and we want to write one quantity as a percentage of another, we just use this formula. We just turn it into a fraction, and the way we go from a fraction to a percent, we times by 100 and stick a percent sign. So here's an example. School of 300, 216 have brown hair. What percentage of students is this? So the fraction of students with brown hair is 216 out of 300, and the way we turn that into a percent is times by 100 and stick a percent sign on the end. So on your calculator, you just put this part without the percent sign, so that will give you 72, and you just write as a percent. So 216 per 300 is the same as 72 per 100. We write percentages and use them because they make for easy comparisons. Now we can use one quantity as a percentage of another to calculate the percentage change. So let's say, for example, I buy books for $15, sell them for $24. We're going to calculate the percentage profit. So the profit is just the difference between how much you sell and how much you buy something. It's the difference between the selling price and the cost price. So in this example, the profit is 9. That is the change. That's what we mean by this formula here. The price has changed from 15 to 24. It's gone up by 9. Now, when we're calculating percentage change, it's always over the original. It's what you started with. So in this case, it's not 9 over 24. It's 9 over 15 over the cost price. And then we simply change this fraction to a percent by timesing by 100. So 9 over 15 times 100 is 60, and then we stick a percent sign. The profit is 60%. All right, let's now move on to finding a percentage of a quantity. So a percentage of a quantity is kind of the opposite of what we were doing on the previous slide. See, on the previous slide, we were calculating the percentage, but here we know the percentage. We just convert it to a fraction or decimal and multiply by the quantity. So for example, let's say 90% of our class of 30 students are going to score an A in this maths test. And how many students is this? So we're just really being asked here to calculate 90% of 30. So we already know the percent this time, and we're calculating a quantity. So we just convert 90% to a fraction. 90% is the same as 90 over 100. You can also convert it to a decimal. 90 divided 100 is 0.9. It doesn't matter whether you go fraction or decimal, we'll get the same answer. In either case, you just multiply by the quantity. The quantity here is the 30 people. So 90 over 100 times 30, or 0.9 times 30 gives you 27. In both cases, if 90% of 30 students score an A, that is 27 students. We don't put a percent sign here because our answer is another quantity. Here it's a number of students, it's not a percentage. So we can use this idea, percentage of a quantity, to calculate percentage increase and decrease. So let's say a fragrance normally costs $440 but is discounted by 15%. Calculate the new price. So you can use this formula here when you're performing a percentage increase, and this when you're performing a percent decrease. Note in both cases R is the rate. It is the percent by which you're increasing or decreasing. So if you want to discount or decrease 440 by 15%, you take your quantity, and this time we're going to times by 1 minus R over 100, minus because we're decreasing. R is 15 because it's 15%. So 1 minus 15 over 100, that's actually 85%. If you take away 15%, you're left with 85%. Essentially, we're just finding 85% of 440. That's why it's the same as finding a percentage of a quantity. So putting that straight on our calculator, we get 374. Now, because we're talking money, make sure you include the dollar sign. So that will be the price after the discount. All right, let's now look at a harder question involving percentage increase and decrease. So the price of an item is increased by 25%, the new price is discounted by 20%. What percentage of the original price does it now cost? So we want to know, does it cost 90% of what it started or 100%, whatever. So this answer that we get will be the same regardless of what the price was when we started. So you can pick any price you want. So let's just say the original price of the item was 100%. If you increase 100% by 25%, you times by 1 plus 25 over 100, then you get 125. So now we're going to take 125 and we're going to decrease that by 20%. So that one's not as easy to do in your head. You just go 125. Now to decrease by 20%, you times by 1 minus 20 over 100. And it turns out that you actually get 100. So obviously the answer is 100%. The item now costs 100% of the original price. It costs what we started with. It's a bit counterintuitive. If you increase the number by 25%, you need to discount it by less than 25% to return to the original. All right, let's now have a look at finding the original amount. So on the previous slide, we found that when you're calculating a percentage of a quantity, you multiply. You multiply the percent, written as a fraction or decimal, by the quantity. But when you're calculating the original amount, you divide. So what do I actually mean by calculating the original amount? Well, let's illustrate this through an example. So my team has won 80% of our matches. We've won 36 matches. How many have we played? We're finding the original amount here. We're not saying what's 80% of 36. What we're saying is we took 80% of the total number of matches played, which we don't know, and we got an answer of 36. This was the original amount. We're finding what number we started with, did something to it to get 36. In this case, what number, when you take 80% of it, gives 36? So when finding a percent of a quantity, we times, but because we're finding the original, we're just going to divide. All we're going to do to find the number that goes in the box is take 36 and we're going to divide it by 80%. So you can write it as a fraction or decimal, either 36 divide 80 over 100 or 36 divide 0.8. Either way, you get an answer of 45. The answer is 45 because if you take 80% of 45, then you get 36. All right, let's try another example. The selling price of an item is 400. It's been marked up by 20%. Calculate the cost price. So remember that when we mark up or increase a quantity by a percent, we times by 1 plus r over 100. So to increase by 20%, we times by 1 plus 20 over 100. But because we're finding the original amount here, we're going to divide. We're not increasing 400 by 20%. We're saying what number do you start with, then increase by 20% to get 400. So instead of going 400 times 1 plus 20 over 100, we're going to go 400 divided by 1 plus 20 over 100. So the answer we get is 333.33333. What we do when we're dealing with money, just give 2 decimal places. So $333.33. If you start with this price here, which is the cost price, and you add 20% to it, you get the final or the selling price. All right, that's all for percentages. Let's now go on to ratios. So suppose that our class has 10 people with blue eyes, 20 with brown eyes, and 5 with green eyes. I'm going to start by writing the ratio of blue to brown to green eyes. So blue is 10, brown is 20, and green is 5. Now, just like fractions, we can simplify ratios. We do that by dividing each number in the ratio by their highest common factor. So the highest number that goes into 10, 20, and 5 is 5. So we get 10 divided by 5, 20 divided by 5, and 5 divided by 5. This is the simplified ratio. So what does it mean? Well, here it's dividing the class into 2 plus 4 plus 1 into 7 parts, or 7 equal groups. One of those parts has students with green eyes, 4 of them have students with brown eyes, and 2 have students with blue eyes. It allows us to compare quantities. So we can see from this there are twice as many students with blue eyes as green eyes. There are twice as many students as brown eyes as have blue eyes, for example. So there are 7 parts, one of which is green, so that means in this class 1/7 of the class, for example, have green eyes. If we wanted to calculate percentages, we know to go from a fraction to a percent, we just times by 100. So if I want the percent of students with green eyes, I just take 1/7, times it by 100, add a percent sign, I get about 14.29% of the class has green eyes. All right, let's now take a look at using ratios to find quantities. So just as we have equivalent fractions, we can have equivalent ratios. For example, you probably know something like 4 to 8 is the same as a half. And just like that with ratios, 4 to 8 is the same as 1 to 2, because ratios essentially are fractions. So these two ratios are equivalent because what we've done to the first number in each ratio, we've done to the second number. Just like for fractions, they're equivalent as long as what you do to the top, you do to the bottom. So let's use equivalent ratios to find quantities. So the boy-girl ratio in our class is 3 to 2. If there are 12 girls in the class, how many boys are there? So boy to girl ratio is 3 to 2. Because we said boy first, that means this number represents boys, this number represents girls. Now we're told that there are 12 girls in the class. Essentially, what we're doing is finding an equivalent ratio. What number goes there? Well, the two ratios will be equivalent if what we do to one number in the ratio, we do to all the others. To get from 2 to 12, we've times by 6. So if these ratios are equivalent, we must also times the first number by 6. Of course, 3 times 6 is just 18. There must be 18 boys because 18 to 12 is the same as 3 to 2. All right, let's now look at dividing a quantity in a given ratio. So let's say the length to width ratio of a rectangle is 7 to 5. The perimeter is 1260. We're going to calculate the dimensions. Now, important to note here, if you have a rectangle whose perimeter is 1260, so it's 1260 all the way around, then the length plus the width adds to half of that, which is 630. This question is asking us to divide 630 in the ratio 7 to 5. So how do you divide a quantity in a given ratio? Well, what you do is find the value of each part. Remember I said ratios divide things into equal parts or groups. So this has 7 plus 5, 12 parts. So if 630 is 12 parts, each part will be 630 divided by 12. So 630 divided by 12 is 52.5. So if each part's worth 52.5, then 7 parts will be worth 7 times 52.5. 5 parts will be worth 5 times 52.5, which is 262.5. So what will the dimensions be? The length will be 367.5 centimeters and the width 262.5 centimeters. All right, let's try a similar but harder question. So we have another rectangle. The length to width ratio is 7 to 5, but this time the area is 1260 and we're going to calculate the dimensions. So this is a bit harder because we're not saying that the quantities add to 630, they actually multiply to 1260 here. So what we do is we're going to let the length be 7x and the width be 5x. This is what it means if the ratio is 7 to 5. The length is 7 times a number, and the width must be 5 times that number. The length is 7 parts, the width is 5 parts. Here, x is like the value of 1 part. So because the area is 1260, we have length times width is equal to 1260. Now, when we're multiplying these, most people know to do 7 times 5 is 35, but you have to multiply the x's. X times x is x squared, not just x. So it's 35x squared equals 1260. So dividing each side by 35 gives x squared equals 36. Now we square root each side, we get x equals 6. That means each part has a value of 6. So that means that the length, which was 7 parts, is 6 times 7, and the width, which was 5 parts, is 5 times 6. And there we have it, length 42, width 30. All right, let's now look at rates. So whereas ratios compare two quantities of the same type with the same units, rates compare two quantities of different units. So rates are always written as some unit per some unit. An example with which you would be familiar is speed. Speed is distance over time. It's written in meters per second or kilometers per hour, unit per unit. So let's say I walk 1 kilometer in 6 minutes and 40 seconds. We're going to calculate the speed. We're going to write this as a rate. So 1 kilometer, I hope you know, is 1,000 meters. Now, this is a bit annoying because we've got minutes and seconds. So let's convert this just to seconds. Well, 6 minutes is 6 times 60, 360 seconds, plus an extra 40. 6 minutes and 40 seconds is 400 seconds. So I am walking at 1,000 meters per 400 seconds. So 1,000 divided by 400 is 2.5. You can use your calculator for that. I am walking on average 2.5 meters every second. Doesn't mean I go exactly 2.5 meters every single second. This is just an average. So 2.5 meters per second. Now to convert meters per second to kilometers per hour, you times by 3.6. So 2.5 times 3.6 is actually 9. So my speed is 2.5 meters per second, which is 9 kilometers per hour. Obviously, if you want to go kilometers per hour to meters per second, you would divide by 3.6. So this is saying that if I kept up this pace for an hour, on average, I would go 9 kilometers for every hour. All right, let's now use rates to find quantities. So at this rate, how far can I run in 30 minutes? We're also going to find how long it would take me to run 8.5 kilometers. Now, when doing these two questions, the problem that most people encounter is when do you times and when you divide. So the way I explain it is this. In each rate, you have a first quantity, and you also have a second quantity. When you want to find the first quantity, you times. When you want to find the second quantity, you divide. So in this one, how far can I run? I am being asked for distance. I am being asked to find the number of kilometers or meters. I'm being asked to find the first quantity. That's why I times. So if I can go 9 kilometers per hour in 30 minutes or half an hour, I'm just going half that. I'm going half an hour times 9 kilometers, and that obviously gives me 4.5 kilometers. If I was asked how far I could go in 2 hours, it would be 2 times 9. I'm timesing because I'm finding how far, I'm finding the first quantity. Now in this second one, at this rate, how long would it take me to run 8.5 kilometers? I'm being asked to find the number of seconds or hours. I'm finding the second quantity, which is times. So that's why I need to divide. So at 9 kilometers an hour, how long would it take me? I just go 8.5 kilometers per 9 kilometers per hour. Now 8.5 divided by 9 actually gives me an annoying number, 0.944444. So on, it's a recurring decimal. Now because this is hours, my answer is going to be in hours. So that doesn't really make sense. How do I turn that into minutes? Well, all I do is times by 60. So this is 56.6 recurring minutes. So I just got from here to here by timesing by 60. Now, hopefully you see this is 2/3. 2/3 of a minute is 40 seconds. So it'll be 56 minutes and 40 seconds, how long it will take. All right, now we're going to look at more problems like this using the unitary method. So we're going to solve the problem. If 30 litres of petrol costs $51 at the same rate, how much would 50 litres cost? We're going to use the unitary method. What that means is you calculate the value of 1 unit. So in this case, each unit is a litre of petrol. We're going to calculate how much 1 litre of petrol will cost. And that's exactly what rates are. What we really want here is the cost per litre. So what we do is divide the dollars by the number of litres. That's what this says, dollars divided by litres. Now, if you put that in your calculator, you get 1.7. That means each litre of petrol costs $1.70. It's $1.70 per litre. So I want to find now how much. So I want to find the dollars for 50 litres. Because I'm finding the first quantity, I simply times. So it'll just be 50 litres times $1.70 per litre gives me $85. So how much petrol could I buy for $100? So this time I am being asked to calculate how many litres. I'm calculating the second quantity. When we're calculating the second quantity in a rate, we divide. So it'll be 100 divided by $1.70. The answer I get is about 59. I've rounded it to the nearest whole number, and it will be litres. So about 59 litres would cost $100. So unitary method, calculate the rate first, which is the value of 1 unit. All right, let's look at a harder rates question now. So suppose I walk to the shop at 4.5 kilometers, jog home at 7.5 kilometers, calculate my average speed. So a lot of people here would say, okay, it's just halfway between these two numbers, which is 6 kilometers per hour. Now it doesn't work like that because you spend a lot more time walking at this speed than you do running because you're obviously going slower. So how are we going to calculate it? Well, when you're doing something like this, it really doesn't matter what the distance was. It doesn't matter whether the distance to the shops was 2 kilometers or 10 kilometers. We're actually going to get the same answer for average speed. So let's suppose that the distance to the shops was 4.5 kilometers. So if I walk at 4.5 kilometers per hour, it will take me 1 hour to go 4.5 kilometers. Hopefully you see that. So how long would it take me to jog at this speed? Well, if I'm going 4.5 kilometers at 7.5 kilometers per hour, it'll take me this many hours. So using our calculator, 4.5 over 7.5 is 0.6. It will take me 0.6 hours to go 4.5 kilometers jogging at this speed. Of course, 0.6 times 60 is 36. It's 36 minutes. So what this means is I would have traveled 9 kilometers. So I'd have got 4.5 kilometers there, 4.5 kilometers back, and the total time it took was 1.6 hours. So if I want to know the speed in kilometers per hour, I just go speed equals distance over time. How far I went over how long it took me. So you can use your calculator if you need. 9 divided by 1.6 gives us 5.625, and it's kilometers per hour. That is my average speed. It's not halfway between these two. It's closer to 4.5 because I spent far more time at this speed than at this speed. All right, that's all for the mainstream part of the test. So if that's you, best of luck studying. You will absolutely ace it. But I'll also go through some advanced questions now for LEAP students. So the advanced questions I'm going to go through all involve equations. I'm going to do one percentages, one ratios, and one rates question. So let's calculate the percentage increase per year if the population of a city doubles every 40 years. So we know that the equation you need when you're increasing by the same percent each year, A equals P 1 plus R over 100 to the power of N. So here we're increasing by the same percentage each year, so we're increasing the population at an increasing rate. Now, if we want the population of the city to double, then A will be 2P. I want A, the amount that exists at the moment, the population at the moment, to be double what it started with. Of course, we can divide each side by P. We also know that N is going to be 40. So if it increases each year for 40 years, there's 40 increases. So we're solving this equation here. 2 equals 1 plus R over 100 to the power of 40. So we have to actually take the 40th root here if we want to get rid of that power of 40. Now to get R by itself, we now need to subtract 1 from both sides, and then we need to times both sides by 100. So this is the value of R exactly. So putting that in our calculator, we get R is about 1.75%. So population of the town increases about 1.75% year on year. It will double every 40 years. All right, let's look at a ratios question. So J and K share a prize in the ratio 4:3. If J received $40 less, K received $40 more, ratio would be 8:7. How much did each person receive? So we're going to let the amount J received be 4x and K be 3x. That's what the ratio 4:3 means. J got 4 parts, K got 3 parts. Here, X is the value of 1 part, and we know the prize was divided into 7 parts. Okay, let's form an equation. So if J received $40 less, he would have received 4x minus 40. If K received $40 more, she'd receive what she got plus 40. So we're told that that is the ratio 8:7. So we know that ratios are just like fractions. So we know that if we write this as a fraction, it will equal that as a fraction. So we have 4x minus 40 over 3x plus 40. So the first ratio written as a fraction equals the second ratio written as a fraction. So what we're going to do is cross multiply. I'm going to multiply 7 by this, so 7 by 4x and 7 by 40. So too, I'm going to multiply this by this denominator, 8 times 3x and then 8 times 40. All right, we know how to solve these equations, done them a million times. We've got x on both sides of the equal sign, so we subtract 24x from both sides. Then we add 280 to both, and then we divide each side by 4. So we found out that the value of each part is $150, so J received 4 of those, $600, and K received 3 of those, so she got $450. All right, let's now look at a rates question. So suppose my football team averages scoring 36 points per game, but if we score only 12 points in our next game, then our average drops to 32. How many matches have we played? So when using equations to find quantity, we always start by letting x be what we're trying to find. So let's let x be the number of matches played, because that's what we're trying to find. Now, if we average 36 points per game, we have currently scored 36x points, 36 times the number of matches. If we score 12 in our next game, then our points tally is 36x plus 12. Now, how do we write our average drops to 32 per game? Well, we will have played X plus 1 matches. And if our average is 32, we simply times average number of points by the number of games. This is the equation we solve, and this is a pretty easy equation to solve because we can just expand the brackets and then we subtract the x with the lowest coefficient. So I subtracted 32x from both sides here. Now we subtract 12 from both sides, divide by 4, we get x equals 5. So how many matches have we played? We've played 5 matches. We've scored 180 points. If we score 12 in our next game, we've scored 192 in 6 matches, average of 32. All right, thank you so much for watching this very long video, but you will ace the test. You're a superstar. This has been the luckiest maths teacher in the world. Have a great day.